So when a computer is powered on, the CPU starts by executing the boot firmware. What the boot firmware code does primarily is look on the storage devices, namely hard drives, for a bootable operating system, and from there the operating system starts loading. So the question is, what is the operating system supposed to do? Well, the primary goal of an operating system is that we can use it to run other programs. And in any modern operating system, the expectation is that the operating system allows us to run not just one program at a time, but multiple programs at a time. These running programs, in the terminology of operating systems, are called processes. The main purpose of an operating system is to load these processes to get them started and then to manage them as they run. When processes run on a system, it's the operating system's job to make sure that they don't step on each other's toes. For instance, you want each process to only use its own memory. You don't want it to step on the memory that other processes are using. In a modern system, the operating system and the hardware, the CPU namely, they collude in a way that prevents that from happening. They prevent processes from touching the memory of other processes. Another key part of keeping processes under control and making sure they don't interfere with each other or with the operating system itself is processes should not be able to directly talk to the input-output devices. When a process wants to do some kind of input or output, they should have to make a request to the operating system, which will then, if it so chooses, then do that thing for the process on its behalf. The way that processes make these special requests to the OS is through a mechanism called system calls. System calls essentially are pieces of code in the operating system which processes are allowed to invoke through a special mechanism in the hardware. System calls are the primary mechanism that processes have to talk to the operating system. Giving the processes only this limited means, this limited interface, so to speak, to talk to the hardware is very vital because it ensures that you don't end up with, say, two processes haphazardly trying to talk to the same I/O device at the same time, causing all sorts of unpredictable results. When the operating system has to do this stuff for processes on their behalf, the operating system can make smart decisions about how to reconcile the conflicting demands from the various processes. So if the operating system controls access to the hardware, that means it controls access to the storage devices as well. And in the case of storage devices, operating systems tend to impose not just a limited interface for controlling those devices, but also the OS imposes a basic form, a basic structure for the data that gets written to these storage devices. And this imposed system is called a file system. As you would expect from the name, each storage device stores data in units which are called files. As far as programs are supposed to be concerned, a file is just a big sequence of bytes. On the actual storage medium, however, the file system disguises the fact that the way a file might actually get stored on disk is not necessarily contiguous. It's quite possible that the operating system may decide to scatter the pieces of the file around the storage medium. The idea, though, is that the file system disguises this detail from any process that's reading and writing a file. As far as processes are concerned, a file is always just a logically contiguous sequence of bits, and it doesn't have to concern itself with the details of how it actually gets stored. Finally, operating systems usually provide at least some kind of basic user interface, so that at the very least people can launch programs, and when multiple programs are running they should be able to switch between them. By far, the most widely used operating system, at least on PCs today, is Microsoft's Windows series of operating systems. The most current version of Windows, which is targeted towards workstation PCs, is Windows 7. If you buy a new PC today, most likely it'll have Windows 7 on it. For computers running as servers, however, Microsoft has a more specialized variant, the most current of which is called Windows Server 2008. And then Microsoft has what it calls Windows CE, which stands for Compact Edition. It's the version of Windows that runs on very small devices like, say, smartphones. The primary alternatives to Windows are some OSs which fall under the umbrella of Unix. Unix was the name of a very influential operating system created in the early 1970s. That operating system is really no longer with us, but today we still have a whole lot of modern descendants which are often called Unix-like operating systems. And this includes the free software operating systems Linux and BSD, which stands for Berkeley System Distribution, and it also includes Apple's proprietary OS X, In fact, to originally create OS X, Apple took the existing code of BSD and started building off of that, and then released it as their own proprietary operating system. The license of BSD actually allows you to do that. So these are the primary examples of today's Unix-like operating systems, but there's a good number of others, like say Sun Solaris. Do understand though that unlike the different versions of Windows, which generally have a lot of code in common, in these cases they all have totally separate code bases. They just happen to all follow a similar set of conventions handed down from Unix.